Yes, sir.
Awesome. You can share and we can start the session.
Sure.
Hello, everyone. So, this is Dev Skills channel. We are up with the second discussion of this week about system design. Today, we will be discussing about system design of Uber. Now, everyone knows about Uber. They are in limelight, not because of their ride hailing service. Definitely, they have one of the biggest app for taxi or load of millions of drivers and millions of customers all around the world, and how they uh, manage their app and make it very accurate, reliable for all the passengers. But also, there is a new in just 4 months option of agentic workflows. So they were using resulted is overspending 6 on AI tools in just 4 months. So I have with me Ankit. Ankit is generative AI expert. As you all know, he has various certifications, including the most challenging travel. So you were traveling on weekend and you heard about this
Uh,
news. What's your opinion on it?
yeah, I was also traveling, so I heard this news while I was like, I was on the airport, so I was just opening LinkedIn and like saw that. So I felt good because I came to airport by Uber only. At least I contributed to their economy.
Okay, great, great. Yes. So the funny thing is, and in that token maxing culture, they rewarded employees, developers mainly, to build agentic workflows. But the side effect was developers paid less attention on optimizing the workflow, and they built a lot of agentic workflows. There is slight difference between normal coding assistant, AI powered coding assistant, and agentic workflow. In coding assistant, what actually happens is few lines of code is sent to the LLMs for recommending the code. So it's like very limited usage, and number of tokens which are used is very less. But in agentic workflow, all of us who are developers and engineers, they should be very much aware about this, that when you run some workflow, your entire repo may result in large amount of token getting used. Workflows are not optimized, and it will multiple times uh, run loops through the entire repo code base. So that is very expensive, and that we all as a developer should be very careful about. And definitely this creates an opportunity. I see that, okay, at enterprise level, so that no management can ensure that AI tools and agentic workflows are being used. Or main culprit was the token maxing culture, where teams were getting rewarded for consuming tokens. Having higher spending was not looked upon as expense, but it was encouraged. But they got good agents. But now let's see in coming days how much business value they were able to deliver using all these agentic workflows. So let's now come back to our system design discussion. Great. No, I just introduced about this Uber latest news. So that yes, we can get some context, but we will now talk about the great architect managing scalability, having an app which can in real time show the uh, drivers availability ETA for passengers and can get them picked up and dropped to their desired location. So all of you know about Uber. So let's start. We will do a kind of a mock interview. We did just a couple of days back interview on web crawler. Now with Ankit, I'm doing again is the interview, and he is getting considered for a position of senior software engineer. And yes, so he will be answering as if he has to crack this, and I have set a very high target for him that he should try to get 5-star rating this time, uh, so that he can get highest band and highest uh, salary and rewards when he get hired. Perfect. So Ankit,
Yeah,
welcome for your system design round of interview, and let's start directly to the point. So for you,
sure,
you can share a diagram tool or share your screen. Your goal
sure,
is to design Uber. So give me the
sure,
system design, high level design of Uber app, or the entire
sure,
backend infrastructure of Uber. How would you design?
sure. Do let me know once my screen is visible.
Yes, your screen is visible.
Sure. So I will be starting and I'm just drawing some block diagrams. Just take it as a reference. I will explain passenger with the drivers. That's the main definition of the architecture what we're discussing. So before discussing any architecture, before going deep dive into the architecture or any of the like system design architecture, any of the application what we are defining, I generally follow a trend or I generally follow an acronym which is, let me zoom in first. It's,
Yeah.
so I hope the just again, but the blocks are clearly visible and what I'm writing is also visible. Let me increase the font.
Yes, it is visible.
Yeah.
And
So I
maybe
just
instead of
wrote,
12
yeah,
pixel size of the font size, you may change it to something like 18 or 20. On the right
yeah,
side,
sure.
text. You see the
Yeah,
text
I think it's,
tab on the right
yeah,
side.
yeah, yeah,
Yes.
yeah.
And then here 12, you can make it instead of 12 pixel.
Let me make it to 20 or 22. Yeah.
Yes, perfect. Okay, cool. So that way you will get, yeah, pattern visible.
Yeah.
Awesome.
Okay.
Perfect.
So let me increase the font of this also. Yeah.
Great.
So yeah,
Okay.
I have written RCA and HT. What this define is first is the requirement, the second are the core entities, the third is API, and the fourth is high level design, the fifth is data. So before going to any of the system design, we need to focus on the two things, which are the functional and non-functional requirement. So let me write them all, and also I box for functional requirements, and yeah. So so first functional requirement should be user should be able to enter, user should be able to enter the source and destination, because this is the first requirement what we, when we open the app and we like type to search what location we are going through and what is our source location. Then the able to request a right through a proper authentication also. Like user should be registered and it should have a proper authentication also. Which is nearby its area. Match the driver which is nearby, or like time to the should, in which the driver should reach to the person who has raised the request. The fifth should be level right estimated cost. The other one should be it. There should be like push notifications also in this, because we might do which we are putting it that confirms a push notification. There should be a dynamic search price. So I what I have observed is there are dynamic search prices when these are the functional requirements on this.
You
These
have
non,
more functional requirements.
so for functional requirement, yeah, these are the functional one what I can say.
Great. Yeah, looks good. No, these are most of important ones, or I would say the most critical ones, which forms the MVP of any ride-hailing app. So you have
Correct.
about authentication, you have the data entry where you are putting the source and destination, and definitely, I would want users to select the source and destination in the map. It should be able to detect the user's current location, and it should also be able to find out the rider's location or driver's location as well. So there are two users involved here, the driver and the rider. So
Correct.
rider is a person who will enter the destination where he wants to go, and he will be matched with all the nearby drivers. And definitely in
Correct.
Uber there will be many drivers, and the user will be assigned to a driver which is most nearby. And as the driver is moving, the user should get updates about the current. So you have to share design, how would you calculate the ETA, how would you
Right.
calculate the cost estimation, how much is the fare, and if there is any surge price for peak hours, because this is very important business requirement. This makes the business profitable. It
Correct.
will share surge price. So also share what would be the design for giving user surge price. And then definitely this is another important requirement, trip management, where you can view your past activities or current trip as you proceed with the driver. Great.
Yeah.
So
Trip management can also be used if I want to cancel that event in that point.
perfect. So yeah, this
Correct.
awesome. So this is very
And
good set of functional requirements.
and one more functional requirement, what I can call is, suppose if driver is having the shift timing at 5 p.m. So there should not be any request coming to him last statement. Suppose its
Okay,
logout time is 5 p.m. There should not be no request at 4 p.m.
great.
After 4:50.
Awesome. So yeah, these things, there are plenty of such things, but I would like
Yeah.
you to focus on the things which is around supporting millions of users and millions of drivers,
Yeah.
and scheduling the trip, and about calculating ETA and calculating the route, because to the destination, so that they can reach in most
Correct.
optimal way. Sure. So now,
Call is card type. Like that is a non-functional requirement at this time. There should be a proper scalability, availability, I'm just in consideration, latency,
okay,
and schedule a ride in advance. This is also a non-functional requirement.
sure,
Schedule observability should be there. Yeah, that's what I can say. The non-functional requirement should be like summing up onto this architecture.
sure. So yeah, just one clarification here. So about scheduling in advance or choosing multiple car types, these could be considered as functional requirement, because this is about functionality. And what is
Okay.
non-functional requirement is, I call them NRLTs, right? So everything which
Okay.
is like availability, reliability, observability, latency, these are performance. So these are non-functional requirement. Security. And in the previous company where I used to work, they used to call it we should make the releases boring. So anything which makes your application boring, functionalities are interesting for developer to build, but these are reliability, observability, availability, very critical and important. They have business value because they make the app feasible, because this business is only feasible if there are millions of users. So they are the most critical requirement. So yes, you can put for non-functional requirement only these analyties which are
Okay.
not to do anything with the functionality,
Sure.
which user do not see. It is transparent to user, but it is should be the main focus of engineers.
Correct. Sure. So now the third, like one more thing, we can focus on this back of envelope calculation. Since there will be high requests per second, there will be number of active users, there will be a number of active drivers also. So the next entity what I will focus is back of envelope detection, high level diagram, and the deep dives what we can do on this.
Sure. So you can assume, so let me give you some scope for going
Sure.
ahead. So you can assume there are 10 million riders. which are
Okay.
looking for ride,
10
and
million
they are
riders.
active
Okay.
active user daily. So Uber just get around 10 million ride requests every day, and you can say that on average a person takes 2 rides, because
Okay.
when so someone is going to some destination, he'll return as well. So there will be like 20 million, right? If you have say 10 million, and yeah, 20 million per day means now you can calculate how many per hour, but it is not uniformly, because in the late night maybe there are very less requests, but in the working hours, peak office timings, there will be surge. So there could be, maybe you can take it like peak request could be somewhere around
5,000 RPS.
yes,
5,000 RPS would
correct, writes per second, we can call it. So these are other stuff. Then so this is about the users. So drivers will also be lot of drivers. So let's say we have around 1 million drivers, and on average anyway, a driver would be taking 20 rides per day in the entire 24 hours, right? So that seems fine, uh, because yeah, every ride will be around 15-20 minutes on average, because it's all within the city we are considering. So let's not get into outer station all and yeah, you have 1 million drivers, and you should get, what do you think is the best frequency in which we should update the location of the rider or a driver?
1 update per second.
Perfect. Okay. So let's say that, okay, we would be updating the location of driver every second. Sounds good. So that, no,
And yeah, and for this also, for updating requests per second, I think there should be a cron job which should be monitoring. Like what I have observed in Uber, like when I was like driving, when I was like for the next ride. So there should be this mechanism also when like we are able to reach our destination, a cron job should be running, which should get the driver the next ride. And he should have at least 10 to 15 seconds to either accept or decline it.
sure. So yeah, I would like you to act like an architect for this app. So assume you are the chief architect for this app. So do not worry about what is there, but day in next 45 minutes, how would you build it, right? So
Okay.
go
Sure.
ahead. So now we have a good set of non-functional requirements also set. You can proceed to the next steps.
Sure. So the next step would be like complete architecture, what I will be drawing. So let's take an example. So this will be the rider app. Let me increase the font. I'm not sure why it is going to default only. Rider app. And this is driver app. They will be associated through a load balancer. Let me draw a
Sure.
load balancer.
Sure.
Okay, let me erase that. So this should be like attached to a load balancer. This should be one of the rider app, and
Yes.
there should be a load balancer which should manage the load and request.
Can you go through the back of envelope calculation about sizing? What would
There are 10 million riders and active users are 20 million. What we get as a problem statement. Peak request, let's take an example of 5,000 requests per second, and active driver are 1 million. So I would say system should be like what I can calculate is system should be able to handle 100.
when you talk about latency, so for example, if I'm making a request as a rider, I should get
Correct.
a rider to see the driver assigned to the app.
Correct.
for the trip, in the app class experience, because there is always competition. I would recommend that when I create a trip, in less than a second, I should get assigned a driver, right? And I should
Right,
be
right, right. Correct.
able to see the fare and rider, and I should be in a situation to confirm. Because if I have to wait a lot, then no, I have that tendency to switch between different apps and make a request through, say, Ola or Lyft or other
Hmm.
apps. Now there are plenty
Hmm.
of them. So you have to design in such a way that it is lower latency. So it should be able to assign a driver in less than a second.
Yeah.
So yeah, go ahead. So I understand there will be various components. So you have a rider app, you have a driver app, then they will be talking to API gateway. So they will be anyway
Yeah.
connecting to the APIs. So what kind of architecture will you use for the back?
Before I move on, so API gateway will be handling our auth rate limit and everything, like request and like what I can say, request orchestration and everything will be handled for API gateway. So API gateway like basically handles our most of the requests when it act as a gateway to what I can say to manage the incoming and outgoing requests to our applications.
Okay. And what are the
Yeah.
functionalities it handles?
So functionality, it can handle the rate limiting and like it can be used for request routing, what I can say. It can be used for caching, load balancing, logging and monitoring, request transformations. These are the main functionalities it can handle.
Awesome. Perfect. So yeah, API gateway is a
So
layer.
basically API gateway, like to be summarized more, API gateway like is a micro like handles a microservice architecture and act as a front door for it.
Perfect. Perfect. Yeah. So in microservices, we have many services, and API gateway takes care of all the cross-cutting observability, sometimes also request orchestration as well. So this enables all the cross-cutting concerns. I mean that these need not have to be implemented on each of the microservices. So this provides better organization of the code, and various microservices just focus on the business logic rather than on
Hmm.
these standard functionalities or mostly non-functional requirements, like authentication, which is about security, caching, which is about performance, etc. Go ahead.
And it act as a front door. Like that is a so microservices, what I can conclude in this are the which will handle like microservices will be able to handle my load as per our application and they'll help to maintain the latency request what we are seeing.
Mhm. So yeah, you should understand here that with microservice you get the agility of development, because if you have monolith,
Yeah.
any changes you made in any of the requirements, then your entire application have to be redeployed, and there is tight coupling between different services. With microservices you get
And right.
loose coupling, so it becomes more maintainable and testable, and release updates and patches independently without affecting other teams. All the communication between microservices is over the network.
And in my monolithic also I have not chosen because we discussed one of the important feature was scalability. If I like go for monolithic, I need to scale all application at once. But as
Yes,
you mentioned, like it is a single
absolutely.
application containing everything rather
Correct.
than a distributed part of the application.
Correct. With monolithic, the problem is since there are no independent services, everything is together,
Correct.
so you cannot selectively scale. So, for example, in this particular app, number of users who will be authenticating to the app will be different. Number of users who will be browsing the travel history will be different. Number of users who will be raising the request will be different. and finally the number of users who are confirming the ride and going ahead with the ride will be different. So
Correct.
you may have more.
And even if one of the part of our application goes on, it won't hamper the like entire application. I can more.
Tolerance, because since there is loose coupling,
Mm.
if some service is not behaving so properly, the entire app is not affected, only that particular functionality could be.
Part.
Yes,
Yeah.
we can kind of put a fallback for that particular functionality. Great. So this is all
Yeah.
nice points. Very good that you are putting up all these additional points. So perfect. Go ahead.
Sure. Yeah. Just a second. Let me do. So here, like as we discussed, we will be using like this, microservice architectures. Okay, again, it into small size.
Sure.
Yeah. So there will be n number of service. The first will be user service. The second will be what I can say, right management service, RMS, right management service. The third will be matching engine service.
Yeah. So what you
The
can do,
fourth will be
Ankit, you can click on the extras in the
which one?
extras menu at the top. At the top,
Yeah, okay.
extras.
Mm.
Last one at the
Okay.
bottom, configuration. Here you can set the default size, which will be somewhere. It should be
Let me
default
search
font size. Default font size.
for.
Yeah, you got the default font, and it should have the size as well. Yeah, I will give you this JSON, because this is you are requiring here the CSS, correct? So this is
Correct.
this is not that user friendly, but let me give you in the chat the JSON which you can put to set your
This rod and I is not friendly nowadays.
yes, this is tricky, that yeah, you have to use this CSS styling to set the default size. Okay, let's see.
Okay, it is saying changes will affect after the restart of the application.
Okay. So yeah, this is not that like
Okay, so I
microservices.
think
They
from
have
next
a
segment, till the time I can manage this one.
they have a
No worries.
monolith, right? So it's a nice thing.
Correct.
Like, so if you have to restart everything.
Yeah,
So
that's the like live example we got in this session also.
correct. Awesome.
So yeah, for this time we can manage. So the other will be the pricing. What we discussed, pricing, search, service also, which should be like giving the price and managing the dynamic there and everything. The fifth will be what I can say payment risk.
So yeah, this is fine. We have all the microservices for different
Correct.
business logic. Let's
Correct.
focus on probably how will you ensure that there is less latency, and how will you ensure that application or this entire infrastructure is able to scale and handle the number of rides, which is 20 million rides per day, and in the peak time able to do 50 or 5 million 5,000 rides per second.
Correct. So the for this I would be using Redis cache, which will be using session and token. And now the most important things I will be using geospatial index. So what geospatial index is great, like whenever we have an uneven distribution or the density of location on this point. There is another concept also geo hashing, which can be used in our application because it indiscriminate the uneven distribution and what I can say uneven distribution of density, and it's really good when we need to handle a large number of requests. So I can use geohashing if my requests are increasing over my application. But either ways, I will be using Redis on this system. And
Can you
like
give the database design for this particular know what tables and entities you will use?
So for event streaming, Apache Kafka will be used, which will like mention the right request, location, trip,
Okay.
and notification and analytics events.
Okay. So now, what kind of database will you use and what tables will you use?
I will be using database PostgreSQL, which will have user, driver, payments, and rights like columns in it. Cassandra will be managing the trip history and location events.
Okay. Why you
Yeah.
would be
And
using Postgres? Why not
Postgres will
MySQL?
be,
Why
sorry,
not MySQL or MongoDB?
because Postgres I think will be more successful, or what I can say will matching my requirement, because I only need to update user, driver, and
Okay.
the like payments and rights only.
Sure. So you can use any relational database here because you have relationship, you have users, you have drivers, you have trip, and you have start, location, destination. So every trip is having all these details like user detail, driver detail, right? And
Correct.
start time, end time, ETA. So
Correct.
there's a lot of relationships and data which is kept. And then definitely there is payment related information as well. So various transactions which users will payment sometimes through different mediums like credit card, etc. So you are going
Mhm.
with the database which is relational database like Postgres or MySQL. So the choice does not matter much, but what matters is we need ACID properties, that all the data should be atomic, it should be consistent, it should be, there should be integrity, as well as there should be durability, right? So
Correct.
consistency
Correct.
another requirement is there.
And one more thing, I will be also using time service database also, like InfluxDB or Timescale on this point, like which will be having my metrics, locations,
Okay.
because these are also required. Time
Okay.
series data will be there for this.
Okay. So would you need sharding of the databases here?
Starting will be helpful, because it will help me to like split my database into multiple segments, which will be handling my request also. If the load increases, yeah, starting I will be handling on this.
Correct. Because yeah, the data volume is not huge because you are
Correct.
just storing dates and times and
There
geolocation.
is when there is a weekend also or anything, I would make my architecture to handle the request, like high request also, because what I
Okay. Okay. So
yeah,
now how will you handle the geolocation data, because it will have a lot of geolocation data which is about driver's current location and also the start, source and destination of riders for trips. So
hmm,
how would you handle the geographic data and how will you find the shortest path or optimal path for first driver to the rider, and then once they are starting the trip, that the complete path from start location to,
would be using a quad tree or geocaching mechanic. Let me take a line also. So like we can go on depth also for quad tree.
yeah.
So just a second. Oh, it is perfect. This dot out I was somehow hanging on to sometimes.
Yeah.
So like this is a geographic location, and there are four segments. Okay. So what Quantary will do, take a map and recursively it will split into four regions. Suppose these are the four regions. And it will go on splitting into four regions. And then it will be using a nearest k algorithm, and then we will be getting a like proper response on them. So I would be going to quadric and geohashing mechanism to like to handle this problem. As I mentioned, like geohashing also.
Okay. Okay. Perfect.
Yeah.
So perfect. Now what would be the use of, you mentioned about Kafka here, so what would be the use of
Hmm.
Kafka?
Apache Kafka, what I mentioned at this point. Correct.
Yes.
It will be used for event streaming on this point, and it will use my location update, write request. It will handle these things.
Okay.
Basically, what I can say, it will handle my analytic events like trip events, notification, and everything. So Apache Kafka will be very fruitful on this point.
Okay. So now what
Yeah.
kind of event?
Updates, write requests, and trip history,
Okay.
payment. Yeah.
Okay. Okay. So now as different activities are being performed by the rider,
Correct.
you will have an event, and these event will be consumed by different microservices, right? And based on these events, they will make a call to different so they will perform different actions which may involve writing to database, correct?
Correct.
So
And
now,
also for monitoring Prometheus.
well, why do you want
Hmm.
to also use Cassandra?
Cassandra will be what I can say handling my request. What I can Cassandra will be on this point, and like the way we are using geospatial and everything, Cassandra will be the most suitable one on this point.
Okay, yeah, so here
Cassandra will be helpful. Cassandra will be also helpful to store the logs
yes,
on this point. Yeah.
correct, because you have a lot of events which are related to your geographic location updates of drivers. So you don't want to store each and every second one location for every driver because it will kill
Correct.
your PostgreSQL database. So to deal with high volume of data, and even when the trip is going on, you would not want to get this write update happening every second to the PostgreSQL database. So you will use Cassandra, right, for
Correct.
updating the driver location. So now with respect to different function theorem, and then
Yeah.
kind of share me that from perspective of cap theorem, what kind of application we would like to have, what trade-offs we would like to take with respect to consistency and availability.
So basically, CAC theorem stands for like C stands for consistency, A stands for availability, and P stands for partition tolerance. So Uber is a globally, what I can say, globally distributed. So it's like for this, what I can say, partition tolerance will be the most impact, like mandatory one in this. Because in CAP theorem we can focus only on two things. The third thing we need to ignore, like a system can only focus on two things as per the CAP theorem on.
Yes.
So like uh, for this Uber in this point, important one on this point. There should not be any, what I can say, there should not be any fault in this, or there should not be any latency, or there should not be anything breakage of application or breakage of any other service which might cause a delay between a driver or a rider to request a ride or to get a ride.
Sure.
Yeah.
So here, if I have to kind of uh, choose between consistency and availability, so partition tolerance is anyway not within our control because that's about networking, and there is sometimes downtimes happens, network components do go wrong. So if you have to choose between consistency and availability, what would you choose? Is that consistency or availability?
I would use availability in this point because the reason, what I can say, it's like what I can say, it's better to show a nearby driver to my rider or the person who is requesting it. So availability will be the most important thing, and the user want, as per every user, they want every app should respond within milliseconds. There should not be any delay in the request. So availability, I can see that can be the important feature here.
Okay. Want to cover is you have a lot of information about driver which is also stored, like there is a picture
Hmm.
of driver, and there is probably the rating of drivers, and you get other details also like name and since how many years he is with this particular service, maybe some ID or contact detail of the drivers. So how would you
Hmm.
ensure, because there are millions of drivers, So how would you ensure all these information, which also include the media information like photograph of the driver
Mm.
and maybe photograph of the car also, so
Mm.
is available to riders without much latency?
Okay. So I need to think about this.
Yes.
So for this, S3 can be used to store this.
Perfect, perfect.
Yeah.
Because yeah, you can use some object storage. So you
Or
can use,
CDN backlog storage should be used because
yes,
that can be helpful on this one. Yeah.
perfect, perfect, great. So yeah, with CDN and
And
with
also,
object storage,
and also to make sure the system is good and everything, I would store the only the image URL metadata in the database. That can be
okay,
also fruitful for my application.
okay, perfect, great, awesome. So now I am good. So anything else you want to share about the architecture?
So what I can say, if I sum up the architecture, because we are at the end of the session, or we are like, so first of all, it should be rider should request a ride. System finds a nearby driver. We discussed a lot. There should be a geo index, proper geo index should be there. Matching the engine selects a batch, like matching engine service, what we discussed in our microservice, what we are using in front of the like after the API gateway should select the best driver. Driver accepts and the trip is started. Real-time updates should be available, and there should be sharing option also available, so that the person who is riding should share to any of the other person in the family or anyone. This is necessity in our application. Trip ends, payment cost, and how the cost for the kilometer was being calculated. Event stream to Kafka for analytics. Yeah, that's what I can think a key flow of this architecture, similar to Uber what we are designing.
Sure. What are the external services which are being used by this particular app?
What are the, sorry, I did not
External
understand.
services. So will you build everything inside, or you can use some services from third parties as well?
Yeah, I can use some third-party services like for load balancer. I can use Nginx, HAP proxy, API gateway, Kong gateway can be used, or AWS API gateway can be used.
Yeah. No, I was talking about, say, for example, mapping service. So
Hmm.
Google Maps or some other.
Google Maps, yeah, Mapbox will be used.
Yeah, we can use some mapping service,
Yeah.
and you can use payment for payment gateway also. There could be a different service, external service.
Hmm.
But whenever you are using any external service, you have to ensure the reliability, because the external service may be down. So you have to have all the fault tolerance mechanism. So do you
Correct.
know about all the fault tolerance patterns which would be useful in this particular app?
Fault tolerance should be, if I calculate horizontal scaling should be there on this other microservice. Kafka
Yeah.
decoupling should be there.
Okay. So you have decoupling, then you have all the
Database application,
asynchronous
database
request.
application. Yeah,
Correct.
database application should be there.
Right. There should be timeouts also when you are making requests to the mapping service, or when you are making requests to payment gateways. There should be timeout, proper timeout handling.
Correct.
You should have fallback implemented in case some service is down. You may have a fallback. You may want to implement retries. So if some calculation is failing or there is some error, then you may retry, so that this way you can ensure that even if something fails, you can recover gracefully.
Yeah, and there should be, I can also use Kubernetes for auto scaling and self healing, because that is an important tool for orchestration which can be used.
Correct. Now, one more challenging area I see, that you need lot of updates to the app. So on real time, what kind of protocol will you use so that your app is updated, and no, it's making almost one call every second. This may not provide good experience to the users. So what would you use so that the riders get live update about driver location?
WebSocket and gRPC can be used, but I can think of one.
Right. So you can use WebSocket connection between the
Mm.
servers and your app. So when there is a trip going on, or a drive or a rider has requested a ride, then and he has selected a driver, then that particular driver update should be available to him every second. So then you can establish a WebSocket connection so that you ensure that you have real-time communication possible with minimum overhead, and riders see the driver location instantly. Perfect.
Correct.
And
Yeah.
awesome. Good. So we covered you will use quad tree or great. Awesome. Perfect. So this is all about and now one more input I would like to take from you, that if you have to implement any AI ML feature in this, where all we can leverage AI ML to improve the user experience or provide a better app service for our customers.
So for AI and ML, like AI feature I can use for SOS. This is the important thing. If someone need to use emergency feature for
Okay.
this, AI can be used. A
Okay.
chatbot should be implemented in our application, which should send a request if there is emergency or anything which is not going right at this point. And the other thing should be used in, and if I want to enhance my application, I would use AI chatbot in my application, like we have rather than me calculating or
Yeah, so for fare calculation, for pricing, as emergency and customer service. Awesome.
customer support. Yeah. Yeah.
Cool. So that's all about the design of Uber. And let me check if we have any questions from our. Yes, there have been some comments. So I see there is a message from Arc10 2. So they are saying really hard problem. And then I see Money Tay, he gave a thumbs up. So he likes the discussion. So thank you to our uh, participants and viewers who have been watching this. So great. Nice to see your comments. And for viewers who have not subscribed to our channel, do subscribe to our channel. Ankit also has a channel which is Cloud with Golden Jacket. So we'll share about this channel as well. This video will also be shared in that particular channel. So you can see the channel name associated with this video. And you can also subscribe and like this video and keep following for more such system design content. And we will also be soon coming up with a course on system design. So interested people who would like to go in depth about system design concepts, we will provide a complete course on system design where you can enroll and get full guidance starting from understanding each and every concept, how to solve various system design problems, and also you will get access to mock interviews, and we will also guide you to do a project so that which you can showcase in your resume and LinkedIn profile. So this way you will be all set for applying. As I've worked with Amazon, I've worked with Microsoft, and we have cleared various system design interviews. So this course will be for SD1 to any level till director, and beyond that you don't need a system design. So whoever needs to prepare for system design interview, with our experience and knowledge, we would enable you to clear that system design interview. And Ankit has a very good understanding on cloud technologies as well. So he will guide you to build these uh, applications, large scale applications in the cloud. So we'll be covering everything from scalability, horizontal and vertical scaling, to even advanced concepts like deploying these services with the help of Kubernetes and deploying on cloud and integration with AI ML services. So we have also talked in our previous videos about various AI ML services over AWS, and we'll continue to share more content over this channel. Thank you. I see Harish RV also sharing that this is a nice session. So I'm very thankful that you are liking this session. And our goal is to help engineers to do well in their career, or if someone is looking to switch jobs or get into their dream companies, dream jobs. So we would like to help them to upskill themselves and get successful by cracking interviews and doing well in their current jobs by understanding all these complex topics. So we would like to simplify complex topics and make it understandable for everyone. So with this, we can close the session, Ankit. So how do you feel about the today's exercise? I feel you were under pressure and you were doing a lot of right thought, and it was a stressful exercise.
Concepts and over are too much. Yeah.
Correct, correct. Yeah, because good that you took care of covering the entire architecture and we were on time. So in system design interview, you at max get 45 minutes to do everything, starting from functional requirement, non-functional requirement. You have to do back of envelope calculation, understand the scope of the application, and then do the database design, API design, and come up with the high level system architecture, or HLD. I understand there was a little bit of glitches because of draw.io tool. So I also advise all people to kind of keep practicing. Maybe you can try out different tools so that what works for you, you understand. And this also helps because when you communicate with the interviewer, if you are drawing it fast, then that helps a lot. And these screenshots will be taken by the interviewer also to grade you. So this was very good discussion, and with this we can close the session. Okay.
Sure. Thank you, Tarun. Thank you for that. Thank you.
Thank you. See you all. Bye.
Bye.